Back again in section 4.2, we're working on the problem microwave popcorn. Kind of ironic because I'm sitting here right now eating popcorn, so you've got a little bit of my popcorn up there. Not microwaved, I don't really care for microwave popcorn, but caramel and cheese. Nice and yummy snack. Anyway, back to our problem. A popcorn lover wants to know if it is better to use the popcorn button on her microwave oven or use the amount of time recommended on the bag of popcorn. To measure how well each method works, she will count the number of unpopped kernels remaining after popping. To obtain the experimental units, she goes to the store and buys 10 bags each of 4 different varieties of microwave popcorn: butter, cheese, natural, and kettle corn, for a total of 40 bags. So we're looking to solve or answer. Explain why a randomized block design might be preferable to a completely randomized design for this experiment. A randomized block design should remind you of a stratified sample. One's happening in an experiment, one's happening in a sampling method, so an observational study. In an experiment, if we are going to block something, it's because we've identified a variable that might affect the outcome. So we want to block it first. We can look at what's happening within that variable. Then we can look at a whole of what's going on. So in this case, you probably picked up already that those different types of popcorn is likely going to be a variable that could confound our results. So a completely randomized design ignores the difference between the 4 types of popcorn, which will probably result in a great deal of variability in the number of unpopped kernels for both treatments. For example, if there are many more unpopped kernels in bags of cheese popcorn and kettle corn than the other 2 varieties, it will be harder to tell if there is a difference in the methods of popping. A randomized block design considers each variety of popcorn separately, which allows us to account for the variability in the number of unpopped kernels created by the difference in varieties. Again, it's another way for us to try to control for the different variables that are involved in our experiment. The next thing we want to look at is we're going to outline a randomized block design for this experiment. Describe how you would carry out the random assignment required by your design. So first, to explain this out to you guys in words. We will randomly assign 5 bags of each variety to each of the 2 treatments. To perform the random assignment, place all 10 bags of a particular variety in a large grocery bag. Shake the bag and then randomly select 5 bags to be popped using the popcorn button. The remaining 5 bags will be popped using the instructions on the bags. Repeat this process for the remaining 3 varieties. After popping each of the 40 bags in random order, count the number of unpopped kernels in each bag and compare the results within each variety. Then combine the results for the 4 varieties after accounting for the difference in average response for each variety. Now to see this as a diagram, we're starting with 40 bags of popcorn. We're blocking based on type of popcorn. So butter, cheese, natural, and kettle. Anytime you're drawing a design, make sure you specify how many, just like we specified how many when we wrote out our design. We're going to split those based on the treatment. We're either going to press the button or we're going to look at what it says on the bag, and we're going to do that for each of the different types or each of the different blocks. Next, we're going to compare within the variety, so we're looking at just how does the button compare to the bag for butter, how does it compare for cheese, then for natural, then for kettle. And finally, we're bringing them all together to look overall, how do these compare with the 2 treatments. Again, when you're writing your design, make sure you're paying attention to details and being as specific as you can possibly be. Don't leave anything out, don't leave anything ambiguous. Someone should be able to carry out your design when you are done with it.